Simulation models are stochastic in nature, which means that every time you run a simulation model, you will get different results as long as you use different seeds. In order to communicate these varying results to your stakeholders, you need to use a statistical tool called confidence intervals. And this, in basics, will just tell you how confident you can be that your results lie in a particular range or a particular interval. To do this, you need to run Monte Carlo simulations, which in reality is just running the simulation as many times as you need in order for your confidence interval to have the smallest error that you're willing to allow. So on this first video of this two parts video series, we'll talk about the theoretical framework behind this idea. So let's get started.
When we prepare a simulation model, we are usually looking to find the value of a certain variable. This variable could be one of many things. It could be, for example, the throughput of the process. It could be the waiting time of customers in a certain service system. It could be the number of agents or customers that do a certain thing. It could be the total time spent in the system, etc. So it could be one of many things. Now, we know that simulation models are usually stochastic models. So running the model one time to find the value that we are looking for is definitely not enough. This is because each simulation run will give a different value. So every time we run the model, we will get a new value. So actually, a good idea would be to run the model for a certain number of times and find the mean of the values that we get. But how many times should we run the model? How many times are enough? Especially that for complicated and heavy models, running the model many times will take too long. So let's say that we choose to run the model, let's say 10, 20, or 30 times to gain some time. And then we find the mean of these values that we get from these runs. So can we use this mean as our final value? What if we decide to run the model again for new 20 or 30 times? Will we get the same mean? Most probably not. So each set of simulation runs, or we can call them replications, because this is actually the term that is used in AnyLogic. So each set will likely give a different mean. So let's try to visualize this. So we run our model for 20 times and we get a certain mean. Then we run for another 20 times and we get a different mean. Then we run a third 20 times or the third 20 sets and we get a new mean, etc. So every time we run our sets of 20, we will most likely get a different mean. And these means will not necessarily be close to each other. So if we repeat this many more times, all these means will be among a certain range. So what we should actually be looking for is not a specific value for the mean. Instead, we should look for a range in which the true value of our variable will lie with a high probability. So in other words, what this means is that we need to find an interval in which we are confident for a certain extent or percentage that if we run again a new set of simulations, the mean of this set will lie within this interval. And this is what we call the confidence interval. But what is a high probability? Well, for the calculation of the confidence interval, the probability is a parameter that we have to decide on and define beforehand. So some of the values that are often used are 95% and 99%, but there are also other values such as 80 or 90%. So if a 95% confidence level is chosen, this means that 95% of the sample means, and by sample in terms of simulation, we mean the set of simulation runs that we are performing. So 95% of the means of these runs will belong to this interval. So in other words, this means that we are 95% confident that the true value of our variable will belong to this interval, Of course, there will always be this 5% probability that the mean we get out of a sample does not belong to this interval. However, this is a small chance that we should be willing to take because it is very difficult to reach a 100% confidence level. Now, once we have decided on our confidence level, we can easily calculate the confidence interval using this simple formula. So Ci, which is the confidence interval, is equals to x bar, which is the mean, plus or minus a margin of error. So we know that our confidence interval should contain the mean, which means that the lower bound and the upper bound of this interval are going to be certain values that we can find by adding or subtracting the margin of error to them. As for the margin of error, we can find it through using this formula. So the margin of error is equals to a t-value times sigma over radical n, where sigma is the standard deviation of the sample and n is the sample size, or equals to the number of replications if we are going to talk in simulation terms. So the sample size is actually the number of replications or runs in a certain set. And finally, regarding the t-value, this value is related to the distribution of the variable that we are looking for. This value in statistics is calculated using a t-test. So the t-test depends on two parameters in order to be able to calculate this value. These two parameters or factors are the confidence level that we have chosen, as well as something that is called the sample degrees of freedom, which is equals to the sample size minus one. So this t-test works well with samples of a small size, such as in our case, when we have a complicated simulation that is slow and will take a long time to run. So it would be really convenient to only run a few simulation runs. But it also works well for large samples when we are capable of running thousands of simulations. So in order to find the t-value, we can use a table. As you can see, this table gives on one side the option of the confidence levels and on the other side the degrees of freedom. Now, there are two types of t-tests, the one-tail t-test or the two-tails t-test. In our case, we are always going to be using the two tails. So in this row, instead of choosing the confidence level, we can choose the value here, which is actually equal to 1 minus the confidence level that we choose. So for example, if we choose a 90% confidence level, 1 minus 0.9 is 0.1. So you can choose this value here, which is basically the same thing, but just for you to know what this means. So based on the confidence level that we have chosen, let's say it is equal to 95%, then we are going to choose this column. And for the degrees of freedom, let's say we have a sample of size 10, which means that we have 9 degrees of freedom. So we are going to choose this row. And finally, the intersection of this row and this column will give us the value that we are looking for, which is in this case 2.262. And finally, this is to note that for all samples that have a size greater than 1000, in this case, the value, the t-value, will not depend on the size of the sample anymore, but it will only depend on the confidence level chosen. And this is why for all values greater than 1000, you will only see this one row for all sample sizes. Now let's look back a little bit at our confidence interval. So we see here that we would hope that for a certain confidence level that we have chosen, that the margin of error turns out to be small. Because having a very wide confidence interval with a margin of error that goes, let's say, 90% over or below our mean is actually a bad thing. So this means actually that it is up to us to choose which margin of error we are willing to accept. So if we look again at the formula of the margin of error, we see now that we need to choose the acceptable margin of error. So we can say that this value is known to us or almost known to us. The confidence level is a factor that we choose by ourselves also. The standard deviation and the mean we can easily calculate from the sample we are working with. And finally, this means that the only factor that is unknown in this formula is actually the sample size. So this means that this is the value that we actually seek to find. And this is where the answer for our question that we asked at the beginning of the video is. So how many times should we run our model? And this formula is the one that we are going to use to find the answer to this question.